So far we have talked about pressure, volume, and temperature, the units, the atomic perspective that we should have on them, but we have not talked about the relationship among them. We will talk about, in this new series of videos, the pressure the relationship between pressure and volume and temperature and other properties. So the first experiment that we will talk about is the one that Robert Boyle did about 300 years ago. He put this kind of a J tube. There was a gas in here, and he kept adding mercury. Okay, something that he observed as he kept adding uh, quantities of mercury. He was measuring the volume that it was being reduced. As you can probably see now, the higher the amount of mercury that you're putting, the higher the pressure. So adding mercury was a way to increase the pressure on the gas. And something that Robert Boyle saw is that as the pressure increased, the volume was decreasing. And something that he saw is that when representing pressure and volume at the beginning at a small pressure, the volume would be still big, and then as it keeps increasing equal amounts of pressure, the volume, however, would not be halved, would actually be diminished in a in this kind of fashion. Okay, so having a kind of a relationship that with the 1 over x relationship would have. So this is what it's called the Boyle's law. The Boyle's law says that the pressure is proportional. We will use this sign to indicate proportionality. Is proportional to the inverse of the volume. Or if you don't like the symbol, we could say that pressure is equal to a constant divided by the volume. Okay. Of course, we can rearrange this. It means pressure times volume is equal to a constant. This is something that Robert Boyle realized. Okay. So it's important because this is a very simple law. All right, and here these are the two forms that I just wrote. These are the two expressions of Boyle's law, and it's important to keep this one in mind, and also to realize how simple the experiment was. But you will have to understand a little bit how this works so that we can apply it. Let's see if we can understand how this pressure versus volume relationship worked. As we mentioned in a previous video, every time there is an imbalance, a pressure imbalance, every time there's a pressure imbalance, there is a flow of gas, or a motion of a wall, or the liquid or water gets pumped up, etc. All right, so let's think of specific common observations that we see in our daily lives that exemplify the relationship between pressure and volume. So let's think, for example, how we breathe. When we breathe, when we inhale, your diaphragm muscle goes down. This means that the volume is, when the diaphragm goes down, the volume increases. By Boyle's law, because the volume is increasing, pressure is decreasing. This is Boyle's law. So by lowering the diaphragm, by Boyle's law, we are decreasing the pressure. Because we are decreasing the pressure, there's a pressure imbalance. This will create, because here's the atmospheric pressure, there's a pressure imbalance, this will create a flow of gas. The same can be said when we breathe out, the diaphragm goes up. This means that the volume gets reduced. By the Boyle's law, if the volume is reduced, pressure is increased. This will create a pressure imbalance between inside the lungs and outside, and there will be a flow of gas going out. Very similar examples can be thought when for example, your ears pop when you go into high altitudes, or as we were saying when we were talking about water pumps, or the very experiment of the 760 millimeters of mercury, a straw will be able to suck water up, or soda, because of the pressure imbalance and because of the same Boyle's law principle, in which in which the pressure is a constant divided by the volume, or if you will, pressure times volume is a constant. Okay. Notice that because there's one single constant of proportionality, if the volume is doubled, it means that your pressure will be halved. Hopefully that makes some sense. Let me repeat that. Based on this proportionality, if you double the volume, what you're doing, because you're putting a denominator, a 2 in the denominator, you're making the pressure halved. Okay, so if you double the volume, it means that your pressure will be halved. This is what this inverse relationship is saying, and this is how pressure and volume, according to Boyle's law, work. Let's do another example. Some of you may have done some diving in your life. So again, the principle that I'm interested in talking about here is that, one, pressure imbalance and Boyle's law. Pressure imbalance and Boyle's law. This is, if you ever go into diving, you have to keep these two phenomena very, very much in mind. On average, every 10 meters that you go below the surface, there is 1 atmosphere of pressure that increases. So for example, if you were to go down, say from 0 to 10 meters deep, at the sea level, the atmospheric pressure is 1 atmosphere. At 10 meters is already 2 atmospheres. At 20 meters is already 3 atmospheres. Okay, the water makes, so if that's you here, there is a lot of water around you. That, remember, pressure is force per square meter. You will feel a lot of pressure. You will feel a lot of force per square meter. Okay, so this means that when you're breathing down here, okay, let's make sure we understand. These are your lungs. We said outside, if you're 20 meters under the water, it means that you have your, not atmospheric, but your external pressure is 3 atmospheres. That means that, let's say that you're breathing through a tank, and here's the tank, okay. In order to create an imbalance, you have the pressure in here has to be higher than 3 atmospheres. If not, if you have less than 3 atmospheres, you will not be able to breathe in any gas, and therefore you will die. It's important that you remember that, because if you are not able to create a pressure imbalance, you won't be able to breathe in any air. Okay, so keep that in mind, and keep these two phenomena, pressure imbalance and Boyle's law, in mind. All right, let's do a short problem, which it's just about substituting numbers. But so, for example, say that you have a cylinder with a movable piston and has a volume of this many liters and these many atmospheres. What is the volume at this many atmospheres? What is this asking? Let's first, I would recommend for any of these problems, draw what it's asking. Okay, here's your cylinder, and this is your piston, and this piston can go up and down. Okay, initially your volume, let's say volume 1, is 725 liters, and your atmosphere at the beginning, so let's say pressure 1, is 4.52 atmospheres. And now it's saying that we are going to move the volume so that we have 1.21 atmospheres. So notice that if the pressure now is 1.21 atmospheres, what is the volume? Well, what we know is that pressure is equal to a constant. Pressure times volume is equal to a constant, which at the same time, of course, that constant is equal to the other pair of pressure and volume, Does that make some sense? So this means that pressure 1 times volume 1 is equal to pressure 2 times volume 2. Alright, so it just takes some rearrangement, because if we want to know volume 2, we just move pressure 2 to the other side, and we just need to do a little bit of calculations, and this will be your volume 2. Now, this is a number. Does this number make sense? Notice that what we said is that as we decrease pressure by Boyle's law, volume should increase. Is this correct? Well, pressure decreased, volume should have increased. Is 27.1 larger than 4.52? Yes. By the extent that Boyle's law predicts, notice that if your pressure was decreased by a factor of 4, your volume should increase by a factor of 4, which is approximately correct. All right, so well, it's exactly correct. It's what it was approximate was the factor of 4.